Hello students, today we will discuss Coulomb's law in vector form, properties of electrostatic force, dielectric constants and some of the numericals based on Coulomb's law of electrostatic force. And these all topics are given in the form of notes for you. After completing these topics, you can note down these topics in your notebook and revise them whenever you need it. Now let us start these topics one by one. First topic is Coulomb's law in vector form. Let us consider XY reference frame having two charges Q1 and Q2 with position vector R1 and R2 respectively. Distance between these charges is given by a displacement vector R12. Let both charges are of same nature, so they will exert a repulsive force on each other, and force on second charge exerted by first let is given by F21 and force on charge first by second is given by F12. According to Coulomb's law and from the figure, magnitude of F12 is given by 1 upon 4 pi epsilon naught Q1 Q2 divided by square of the magnitude of distance between two charges Q1 and Q2. From properties of matter, you know that any vector is equal to magnitude of that vector multiply direction of that vector. From figure, you will see that direction of F12 will be equal to the direction of R21. And using the property of unit vector, R21 unit vector is equal to R21 vector itself divided by its magnitude as shown in the relation. So using these different configuration, we can find out the value of F12 force vector. Using relation first and second, we can find out the relation third. So final relation is given F12 is equal to 1 upon 4 pi epsilon naught Q1 Q2 divided by cube of magnitude of R21 multiply vector R21. So this is the vector form of force. Similarly, we can write the relation for F21 also. Using vector properties, in this relation R12 and R21 can be written as, if you have some problems in driving this relation, then you should have some problems having related to the properties of chapter vector. So if you have some problems relating to chapter vector, then either call me or message me. Our next topic is properties of electrostatic force. It is central force, means electrostatic force will act along the line joining the center of two charges. That is, If Q1, Q2 are two charges and x prime is any line passing through the center of these two charges, then force will act along these lines, that is along lines x prime. That is force on second charge, that is q2 charge, either may be along x prime as shown in figure, or it will be along x prime x as shown in figure, and this direction will depends on the nature of charges. Means if nature of charge is same or opposite. If charges have same nature, then electrostatic force will be repulsive, and if nature is opposite, then electrostatic force will be attractive. According to second property, electrostatic force is a long range force. Means if q is any charge, then its effect can be felt up to a large distance around its neighborhood. And this distance is much larger in comparison to the diameter of the charged particle. It obeys inverse square law. According to third property of electrostatic force, electrostatic force obeys inverse square law. It means electrostatic force is inversely proportional to the square of distance between the center of two charges. Fourth property states that electrostatic force may be repulsive or attractive. Means like charges will repel each other and unlike charges will attract each other. According to fifth law, it obeys Newton's third law of motion, that is action and reactions are equal and opposite. According to vector form of electrostatic force, relation for F12 and F21 are given below. From relation and properties of vector, we know that R12 is equal to minus of R21. So using this property, and from this we conclude that F21 is equal to minus of F12. From figure we can clearly see that F12 is opposite to the F21, and in magnitude these both forces are equal. So these forces are equal in magnitude and opposite in directions. So we'll obey the Newton's third law of motion. Before discussing about dielectric constant, we will do some numericals based on electrostatic force or Coulomb's law of electrostatic force. So first numerical is, what is the force between two charged spheres having charges of 2 multiply 10 power minus 7 Coulomb and 3 multiply 10 power minus 7 Coulomb placed 30 centimeter apart? Means there are two charges. One is of magnitude 2 multiply 10 power minus 7 Coulomb, and second is of magnitude 3 multiply 10 power minus 7 Coulomb, and both are of positive nature. Means both are of same nature, so they will exert a repulsive force on each other. Distance between these two charges is given by 30 centimeter. Now let us consider charge 2 multiply 10 power minus 7 Coulomb is Q1. Charge 3 multiply 10 power minus 7 Coulomb is denoted by Q2. And distance between these two charges, which is 30 centimeter, is denoted by R, and we know that force between any two charges is given by, this is the relation between the force, this is the relation for the force between two point charges q1 and q2 which are placed at a distance 30 centimeter from each other. Now put the values of different terms in this relation. So value of 1 upon 4 pi epsilon naught is 9 multiplied 10's power 9 in SI system, and value of q1 and q2 and r is 2 multiply 10's power minus 7 and 3 multiply 10's power minus 7. Because every terms is taken in SI system, so we have to take value of R in also in SI system. So we have to take this value in meter. So first we convert 30 centimeter into meter, and value of 30 centimeter in meter is 0.3 meter. So by putting this value in this equation and after solving, we will get, so value of force will be equal to 6 multiply 10's power minus 7 Newton after solving this. So this is the numerical based on this topic, and we will do some other numericals also, but in next video.